I'm going to walk through the chi-square test for independence with you, going through the entire process, all 4 steps. So using our independent variable of preference of animal, if we were just using preference of animal and looking at frequencies of preferences, it would be a goodness of fit. But because I've thrown in another variable, I'm throwing in gender as well. Now we have 2 variables. So we're looking at a relationship between preference of pet or animal related to gender. So for our alternative hypothesis, we could just basically state as simple as there will be a relationship between pet preference and gender. So it's just basically our 2 variables. So, here's our pet preferences and here's our gender categories. So the 2 different categories. And so that would be our step 1. Our step 2 would be setting the criteria. So to set our criteria, we're basically going to take the degrees of freedom for group 1, so k minus 1, and we'll say gender is group 1. It's 2 minus 1, which is 1, and we're going to multiply that by k minus 1 for the other group. So dogs, cats, birds, reptiles is 4 different categories, minus 1, that's 3. And so our degrees of freedom, 3 times 1 is 3. And let's say we're going to use alpha equals 0.05. We're going to look that up in the back of the textbook and look at the 0.05 column and then find the degrees of freedom for 3. And we're going to go ahead and we'll notice that our critical value equals 7.81. So now we have basically our step 1 and step 2 completed. So step 1 and step 2 completed. So now we need to move towards step 3, which is calculating the test statistic. So what we need to do is get our expected frequencies. Go to the next page, and I have extra room here. So what we want to do is get our frequency of the rows here, and then we want to get our frequencies of the columns here. So it's basically just adding up the categories in the row and then the categories in the columns. So if we work on the first column, which is the dogs column, it's 19 plus 18, so that frequency column is 37. And then the cats column is 11 plus 13, that's 24. And then the birds column is 7 plus 4, that's 11. And then the reptiles column is 12, 8 plus 4, right, is 12. So now we have our frequency of the columns. Next we need to get our frequency of the rows. So we're basically going to add up all of the scores in each of these rows, right? So 19 plus 11 plus 4 plus 8 is 42. And then 18 plus 13 plus 7 plus 4 is also 42. If we add up 42 plus 42, it's 84. If we add up 37 plus 24 plus 11 plus 12, it's also 84. So 84 is our N, equals 84, our total sample size. Okay? So now that we have our frequencies of rows and our frequencies of columns, we can start using our expected frequencies equation. So it's the frequency of the column times the frequency of the row divided by n, and that's for each cell. So this is where I often kind of number my cells, just to make my life a little bit easier, okay? So I'm going to number this one 1. Oops, sorry, this is the wrong pen. Okay, so this is going to be row 1, row 2, or cell 2, cell 3, cell 4, cell 5, 6, 7, and 8, okay? That way I can just keep organized. So is what I typically do is I go in and I just kind of calculate each one separately. So I'm going to put here the number 1. So that is for the cell number 1. So I'm going to look at its column frequency. So basically I'm going to look down here at that and then at its row frequency over here. So it's just lining them up. And then once you get them lined up, you just start plugging in. So is what I end up with. So I have expected. I have 37 times 42 divided by 84. Okay? So I just set these up. I'm going to set each of them up. The expected for cell 2 is 24 times 42 divided by 84. Then cell 3 is, expected frequency is 11 times 42 divided by 84. So a lot of this is repetitive, but it seems repetitive, but there could be variations depending upon whether you have a 2 by 3, a 2 by 4, etc. Then when we go to cell 4, it's 12 times 42 divided by 84. Now we're going to jump to cell 5. Okay, so cell 5. Again, we're just lining things up. It's, this is cell 5, so the column for the female preference of dogs, that cell is 37 for the column and then 42 for the row. So again, we have 37 times 42 divided by 84. And for 6, we have 24 times 42 divided by 84. For row 7, we have 11. So this is where the repetition comes in, times 42 divided by 42. And the reason why there's repetition, not 42, sorry. The reason there's repetition is because there's equal sample sizes in the males and females. But that's not always the case, so be really careful about that. And then for cell 8, we have 12 times 42 divided by 84. Now the nice thing is I can just do each of these 4 or for one row, and then I can just duplicate the others because we know that they're the exact same. So if I look carefully here, 37 times 42 divided by 84 equals 18.5, okay? So I'm going to put here 18.5. We know this is 18.5, right? So we have that one. We have this one. Now we're going to do 24 is what I do is put parentheses so that we're making sure that the order of operation is maintained. So 24 times 42, close the parenthesis, divided by 84. So this is 12. So we know this one is 12 because these are the same equation, right? Over and over. Then we have, for cell 3 and 7, 11 times 42, right, divided by 84. That's 5.5. Sorry, this is sloppy. 0.5. We have 5.5 here. And then the last two is 12 times 42 divided by 84 is 6. So that means this one is 6 too. So now we have our expected frequencies. So we can literally calculate our chi-square equation now. So if you recall what our chi-square equation is, we'll go ahead and move forward to calculating through. And I'm going to write the equation. Bear with me. Okay, so if we look carefully, here's our chi-square equation. I'm going to write it up here in red. Okay, so chi-square equals the sum of the frequency observed by the frequency expected squared, all divided by the frequency expected. So you'll have one of those little fractions for each cell, and then you'll have to add them up. So we had 8 cells. So we're going to have 8 little chi-square equations. So basically, we have everything we need now. So let's focus on cell 1. The observed frequency was 19. Our expected frequency was 18.5, right? And then that's squared divided by 18.5. Then for cell 2, the observed frequency was 11. Minus for cell 2 was 12. Right? Squared divided by 12 plus for cell 3, the observed is 4. 4 minus for cell 3 was 5.5 squared divided by 5.5 plus, let's see, cell 4 is 8 minus, and cell 4 was 6, right? 6. We square that difference, divided by 6. We're going to keep adding, so I'm going to continue down here for cell 5. So cell 5 had 18 observed. The expected was 18.5 squared divided by 18.5 plus, now for cell 6, the observed was 13 and the expected was 12 squared, all divided by 12, plus an observed of 7 minus observed was 5.5 squared divided by 5.5 plus cell 8, the observed is 4 minus the expected was 6 squared divided by 6. So now we have all of those little equations we can add together. So I'm going to give a couple minutes. I'm going to pause this and you calculate, and then I'm going to jump back in and give you my final calculation. Okay, So something that I did is I split it up and I did each of these, like each of the rows, just to make my life a little easier. So for the first 4 cells, I got 1.1726. For the last 4 cells, I got 1.1726. So then we add those two up and we end up with chi-squared equals 2.3452, basically. So 2.35 if we round it appropriately. 2.35. So now we need to calculate an effect size. Because this is a 2 by 4 rather than a 2 by 4 or 2 by 2, we're going to use Cramer's V. So if you recall, Cramer's V is the chi-square divided by n times the smaller degrees of freedom. Okay, all under the square root. So basically, we're looking at 2.35 divided by 84 times 1, because that's the smaller, right? So this Cramer's V would have the same value as if we did a phi coefficient, but it doesn't have the same meaning when we're reporting our statistical results, because a phi coefficient is only for a 2 by 2. So if we calculate this out, I'm going to do this real quick. We should be getting, I got 0.16709, which is basically 0.17. 0.17 is our Cramer's V. So now we can report our results. If we look at this 2.35, let's look at where we were. If you remember, our critical value equaled 7.81, right? Well, 2.35 is here, basically. So let's do this. We're basically over here. So it's not significant. So there wasn't really a significant difference or significant relationship between gender and preference of animal. So, when we calculated the goodness of fit, there was significance as far as preference of animal, but the relationship between gender and preference of animal, there's not a relationship between the two. So we can write our test results. So I'm just taking a little note of my obtained test statistic, which is 2.35, and my Cramer's V, which is 0.17, and then we can go ahead and write, bear with me. So chi-square showed, I accidentally hit the button, no significant, and I'm just going to put SIG, relationship between gender and animal preference. As, and I'm going to just chi-square parentheses. If you remember, our degrees of freedom was 3 that we used to look up our critical value. Our n equaled 84, parenthesis close, equals, and that's our obtained test statistic, 2.35. P is greater than 0.05 because we did not find significance, and Cramer's V equals 0.17. And that is our APA result. So hopefully that helped walking through. Feel free to email me questions or come see me during Cranium Cafe office hours and we can go over this. I'm usually pretty quick about answering questions, but I hope this helps and you're almost done with the semester. Congratulations.